Hello, my name is Nora Lizarti, and today I will try to present an interesting paper made by Smith Kumar and Kathleen M. Kelly. The title of this paper is What to Track on Twitter Streaming API, a Knapsack Bandit approach to dynamically update the search term. This paper presentation is a part of my mobile social network courses in Taiwan International Graduate Program, and this part below Dr. Chih-Ya Shen. Okay, without further ado, let's start this presentation. This presentation have its key point of outline. The first one is motivation. The second one is the problem formulation, and the third one is contribution of this paper, and the next we will talk about the proposed algorithm and about experimental result, conclusion and future work, and the last 2 points of this outline is paper limitation and solution based on my opinions. So first, we will talk about motivation behind this paper. So we all know that Twitter is a famous social media. Many people use Twitter nowadays, and people use Twitter to for many purposes, like monitoring brand, discovering events, and because the Twitter have a streaming API that allow us to tracking the world. For example, about 4 days ago there was an earthquake in Indonesia, approximately in Mamuju and Majene, West Sulawesi, and the earthquake hits the city of Mamuju, and people in that city start to responding to the event. Many people that got impact start to tweet about their situation, and many people that did not got the impact also search to update, to know what is going on the Mamuju. So many research agency and of course the disasters response teams monitor Twitter to find such tweet and to respond to them as soon as possible. And the standard way to monitor events on Twitter is to use the Twitter streaming API that allows tracking search term. Therefore, despite the best effort, in even like an earthquake, often a large fraction of useful tweets do not reach the agencies because they do not contain the exact search term which the agency are monitoring. For example, if the disaster agency is tracking using hashtag earthquake, the agency will miss tweet that contains hashtag Mamuju. So their data collection could be improved by adding new relevant search terms as even on false. For example, by using hashtag Mamuju, hashtag Majene, hashtag Indonesia soon after the earthquake in Mamuju happened. And Twitter has been shown to be useful in disaster. However, this is not the only use case, because Twitter remains a popular source of data both for researchers and also social media analytic companies. And the common approach to collect tweets is to use a set of words of interest as search term to track on Twitter's streaming API. However, as events happen and discussion evolve, the relevant search term change with time, because the conversation is a very dynamic and evolves. Sometimes that search term that very useful in this, however, it might be less useful for the next 2 hours. And of course, the manual monitoring is a very expensive, cumbersome, and error prone. So this begs a question. The question is, can we have an algorithm to update the search term based on the goals of the dataset collection? To answer these questions, they propose an iterative 2-step online algorithm, and this algorithm will have 2 key points. The first one, they will get live data from Twitter using a set of search terms, And after that, they find the next set of search term based on the data retrieved in the previous step or in the last few iterations. And rather than promoting the data collection goal as a set of fixed search term, they approach allow using the goal in a more flexible way, and their solution embed the higher level formulation in the data collection process. So before that, there is another one's problems in Twitter, because we know that Twitter have a limitation. Twitter streaming API only give 1% data for free user and 10% data if we pay the service. We have simulation here. This picture I take from developer.twitter.com, that we can see here that there is a package that we can choose to use the API. The first one is like this is if we want to use it free, we can choose Sandbox. We can access the streaming for 30 days, and we can request like 100 tweet per request, and we can request it 30 requests per minute. So in 1 minute we can collect approximately about 3,000 tweets, and in 1 minute we can collect 3,000 tweets. In 1 hour maybe more, but there is a but here, because Twitter like have a limitation. They only allow us to access to collect the tweet not more than 25k in a month, because we use a free streaming API. And if we want to collect more tweets, we can pay the service. Okay, we can pay the service. We can choose the premium one. This one is lasts for 30 days also, and we can collect 500 tweets per request, and in 1 minute we can get like 60 requests, and so in 1 minute we can collect about 30,000 tweets in 1 minute by streaming. And they have limitation here in 5 million tweets, so we can only take 5 million tweets in a month. So it's a very expensive, because to collect the 5 million tweets in a month, we have to pay about 2,499 USD, and if we convert it to national Taiwan dollar, it's approximately about 71,000 NTD. In Indonesia, it's reached about 35 million rupiah. It's a very expensive to pay for 5 million tweets in a month, because the problem is more red limit, more tweet caps, and more cost. Is that worth it? So that's become a question, that's become a problem. So if multiple source terms are used, the majority of tweets obtained using the API will be from the more commonly used phrase, and searching for more term result in less number of tweets. So they have an experiment. This writer of the paper used like enterprise package of the Twitter, so they have an unlimited access on it. They not use a sandbox or premium one, they use enterprise one. So so they realized that with Twitter API, return data is never exceeds around 25 GB per day, and it's returned around 2,900 tweets in a minute. And as figure shown, the volume of quantity data obtained, they searching about 195 country names for over a week, and they observed that there is a wide variation in tweet from specific country, and still the total volumes of the tweets has remained like between 22 GB and 23, and never exceeds more than 25 GB in a day. So we can conclude that Twitter have limitations, so they have to think about how to minimize this limitation. So they're modeling this problem as a knapsack problem. So what is a knapsack? Knapsack is a bag. Okay, from this picture we can see that this is a knapsack problem. There is a bag, and the bag have a bag have a limitation of about 15 kg. And from our perspective, which one we will use to put with which item we will put into these bags. Okay, we have to find item that not exceed this limitation 50 kg, but we have to put as much as possible, and we have to think about the low cost. We need to find an item that have a low cost but high value. So of course, because of that, we have to pick this one, the green item, because in green item the cost only $4 and the value is 12 kg, and the other have a very low cost but also low value. We have to find low cost and high value. So to solve this knapsack problem, they use Knapsack Bandit. The Knapsack Bandit effectively handle exploration. It's like new search term to explore, and exploitation is keep using the most useful search term and respect the constraint of the data collection, such as number of terms that can be used or the amount of data that can be downloaded in a time window. So from this they believe this paper have some contribution. First one, they believe that with this algorithm, they call this algorithm is DUST, Dynamically Update Search Term. And with this algorithm, they can collect more relevant Twitter data. And actually, this DUST have two versions. The first one is estimate cost and values independently, and it has a limitation. And they improve this first algorithm and fix this algorithm and make a new algorithm, is DUST version 2, to estimate cost and values over multiple time iteration. And the best of their knowledge, this is the first work that suggests a principled approach to dynamically update the search term while staying relevant to goal of the data collection. So we go to the problem formulation. In collecting Twitter data, there is a cost in collecting data. There is some value of the data that collected, and there are some constraints. So they have to solve this problem. So the algorithm that they propose have to solve the three of this problem. So we will talking about the cost. Cost in data collection is due to the cost of data streaming. For example, the internet bandwidth, or even the price that we have to pay for the streaming API, the data storage, and or the data processing. Because these costs are proportional to the volume of the data obtained. To keep their model simple, they aggregate the different costs and call the overall cost as a WI. And where I is the search term index, and so they let xi as a number of tweet retrieved in a minute, and by searching the I search term, and the cost of wi is a function of the amount data. So they expected the cost to be low if the volume of data retrieved is low, but if the data volume is large, the cost should much higher, as it reduces the collection of data associated with other search terms. And the cost function should be a non-linear and should satisfy some condition. The first condition is the cost is proportional to number of tweets collected. If the total volume of tweet is low, so they must be proportional. And if the total volume of the cost is like reach the maximum limit, we know that Twitter have a maximum limit of the tweet in a minute. We have only like 2,900 tweets in a minute. Then the cost would be very high, as we cannot get the data at any rate, higher rate. So they model the cost function as a nonlinear logic function, because they have to approximately make this linear function to the nonlinear. So they have this equation. I believe this is the limit, this is the hard limit of the Twitter that we can retrieve in 1 minute, and this will be the value that they are set to make this equation work for the nonlinear data set. So this is the cost part. So we can see here, for example, we have like 2,899 tweets, and we can calculate how much the cost of this tweet, and it's approximately to 8. This will be the maximum cost. If the tweet have a higher cost than 8, so the tweet will be ignored. So the goal of this cost is encourage search terms that result in a smaller fraction of tweets. So I hope this will be answered the question from Mr. Joshua and Dia as well. So we talk about value. Value is search term I is the mean utility of the data. For example, in the case of an earthquake, the value is a function of the fraction of tweets that are relevant to a real shock. So we call this value VI, where again I is the search time index. So it's estimated based on the goal of the data collection, and could be as simple as a text or pattern match. So if the tweet is matched with the dictionary that they already had, so in this case they have a dictionary that contains earthquake related words. So if the tweet is matches with the dictionary with the pattern, it will be given 1 as a value. If they are not matched, it will be given a 0. So it will become the function of the value. And the third one is a constraint. Constraint is while collecting Twitter data, a critical limitation is the total amount of the data that we can download. As I discussed earlier, it appears that there is a hard limit. Again, there is a hard limit. Here we can see that W must be less than 2,900 tweets in a minute. So Twitter also limits the number of the search term to this point. So to satisfy the search term limit, they have like this equation to fulfill the limitation of the limitation of tweet that can we collect in a minute. So in every iteration is the set of index of the selected search item, and there are other possible constraints, and this constraint have to be minimized by using this equation. So they set the limitation of the key is based on 400. So the tweet must be have under 400 in value and must be more than 1. So that's why. So the cost, the value, and the constraint is the standard approach to model the problem as a knapsack problem. So this is how they use a new search term as a knapsack problem. So first, they solve the simple fraction of the problem, which cost and value are estimated in each iteration. So for this, iteration consists of a small batch of data obtained by connecting to Twitter streaming API for some time. There is a time t1 here. So assume that they put like 1 or 2 minutes to gather the data live by using Twitter streaming. But if the data collection is for the goals, it's like political discussion, so the iteration could be larger time duration, like maybe 1 hour or 30 minutes. But because this is the topic is about earthquake, is a disaster, we need a less time. So they said it's like only 2 or 3 minutes to collect this data, and after 2 or 3 minutes collecting, they have like 4 most commonly tweet that appear in 2 or 3 minutes, and they give that cost value and the cost score and value score on each search term. For this one, earthquake have a very low cost and very high value, so they put it as a new search term, and Alaska is a very low cost and high value, so they put it as a new search term. In baseball, they have a very high cost on it, and the value is very limited, so they ignored this one. And tsunami have a like middle cost and not high in value, say, so they not select this word as a search term. And after that, they repeat it again to the next iteration, because this one, for example, use like 3 minutes for gathering the data, so the next iteration must be 3 minutes plus how much time they want to use to gather the data. So for example, we use like another 3 minutes, so this one will be 3 minutes plus 3 minutes, and they collect and they do another streaming in one key streaming API, and then they collect with the data set and they process, and this is for the next 3 minutes. This is still the earthquake and Alaska still become the value that that have a higher score and less cost on it. And they remove the mega because the cost is very expensive and it has a less value on it, and they put it as like earthquake, Alaska, and tsunami as a new search term. And the iteration will be continued after until they start until they satisfy about the data that they collect. So cost and value for filtered SAMs are estimated using the cost and value function. And knapsack problem have many efficient solutions. So they use dynamic programming based knapsack solver to find the next set of search terms. And they propose this algorithm. The first one is Dust1 and the second one is Dust2. Dust1 algorithm is a dynamically updated search term and have a precondition data is the tweet collected. Like we can see in this pseudocode algorithm, the Dust1 algorithm return a set of new terms and after each iteration, and it's a very useful. And the second one also have a precondition, and data is the tweets collected, and util scores QE is a dictionary of 5 focus that maintain the cost of the value term. So even though Dust1 can collect data very efficiently, it has a limitation. So we have to know about the Dust1 first. What is the limitation of the Dust1? Why the Dust1 have the limitation? So this is Dust1. It's a use a Knapsack Bandit to solve this. So this is a 3 there is a 3 iteration, 1, 2, and 3. In the first iteration, they gather data from the Twitter and they process it, and they set the cost and the value. By the cost and the value, they set the new term. And after that, they do the second iteration. The second iteration, they process it they collect it by streaming API, and then they process it by its cost and value and search the word that have a low cost and high value as a new term. And same as the third iteration, they do the same thing. The problem is they do it not in the same time. First, they have to do this in the first iteration, for example, first 3 minutes, and they have to do this in the second 3 minutes, for example, for 5 to 6 minutes, and then this is for 7 to 9 minutes. So the limitation of this is the approach only consider the current data, and it's ignoring the cost and value estimate in previous iteration. So, and the approach does not consider the confidence in estimating the value of the search term, because this new term, so they ignoring this one. After they do this one, they have a new term, and then they ignoring it. They just try to do another iteration and search a new term. So after that, because of that, the Dust1 have limitation. So they propose the Dust2. So because of that, instead of use only 2 hands in Knapsack, only 1 streaming API, they use like a multiple arm bandit. So from this figure, we can see this robot just only have 1 hand, one pair of hand, and this one is have like a multiple arm on it. So in MAB, multiple arm bandit, okay, they do iteration in one time action. So in the same time, they collected data in a different KAB, and then it's they collect the data, and then they process it, and they determine it with a low cost and high value, and they find the new term. After that, they find the best with the cost and value. After set the best new term, they start to explore it. Of course, this one also have a limitation, because to improve that, the MIB needs strategy to maximize the results. First one, they use mean case strategy. Mean case strategy is like estimate the mean of a function value or cost over the last k iteration. And so the mean value of search term is over last k iteration, and they try to find the mean of the k, which one is the best. And the second one strategy is upper confidence bound. It's like the UCB strategy allows for better exploration by giving higher probability to action for which reward estimate is not available. So Dust2 algorithm is a simple, but we found some practical limitation while implementing it. First, cost and value estimation of some search term gets stale over time. And second, the large number of search term needs to be tracked, so we get more and more data, which will be slow down the algorithm. So we have get it back to this one. Okay, they do in one-time action. For example, they take like 5 minutes to do this exploration. Okay, to do this exploration, and they like collecting data in the same time. First one we have to thinking about, they use 3 kind of machines, so it might be high computational. Maybe in time it's more efficient, but in time so it's make this action will make the algorithm will be slow. And second, they find the best new term, and after that they use this bit of this, which are the best search sum. So from this they choose one, and after that they use this search sum to explore for the entire time when they gather the data. And the problem is this term will be stale because they do not do another iteration after they find the best. So that becomes the limitation of the Dust2. So because of that, we can they do like to resolve that problem. They use like a FIFO query for limited size to store the cost and value of each search sum. And in addition, if they don't get a data for a search sum and iteration, for example, an empty cost and value is added from the term to the query, and with this modification, they are able to get rid of the stale data, but they still keep on aggregating all search terms to fix the P point of this. After every iteration, they run a subroutine that remove any search term that contains only empty in the query. So that's the solving for the Dust2. And we go to the experiment. So they conduct a data collection experiment for a few weeks to measure the quantity of the relevancy of the data collected using the approach. So their goal is collected tweets that are relevant to earthquake beyond what could be obtained by using the seed search sum. So to compare different approaches, they collected data in 4 different ways. First, searching with search term using like earthquake and hashtag word earthquake and hashtag earthquake. And second, searching using the term suggested by Dust1. And third is searching using the term suggested by Dust2 with mean for cost and UCB for value estimation. And after that, they use a small tweet dataset from prior research. So they use this. This one is I try to find from source from Imran Premitra. So they use this dataset. This is this dataset is made by Imran Premitra in a paper like Twitter as a lifeline, human annotated Twitter corpora for NLP of crisis related messages. So they use only the Nepal earthquake because the number of tweets is very huge. It's about 4 million number of tweets here, and it's used a language English, and this earthquake is happened in Nepal. So they estimating the value of the tweet by compare the relevancy of the tweet that they collect from the Twitter streaming API with this dictionary, but they remove all the Nepal word in the dictionary, and they do calculated the value by using super factor machine classifier using TF-IDF, and they got the accuracy of this classifier is to be 81%. It's a very high though, and this is the result of the data. We can see here that the Dust1 is exit the data obtained by just searching for search term. This Dust1 have like 1.71 times more collecting more relevant tweet than the only earthquake, and Dust2 have like 0.65 times, and Dust2 with UCB have a 0.53. So the total data that was found to be relevant using the relevancy classifier is like more than 3.89 times to the total data that was collected using only the search term. This is the seed search term earthquake, only that. And this one, the experimental result from the fraction of total that they had. They do an experiment for 6 June to 7 July in approximately about 1 month. So they have a more relevant tweet by using algorithm, but in this paper they do not telling us about which algorithm that have a more relevant tweets. In my opinion, maybe the Dust one, because the algorithm is more simple, and if we see in this picture that only earthquake tweet have a lower relevant tweets. So to summarize it, even if they discount the accuracy estimate of the relevant classifier, that they can always improve with more labeled data, they still expect to gain the approach to be like 2 times the data collected using the search term of this. So they have a very interesting result here. The algorithm can produce a more relevant tweet than only using like a seed search term. For example, this seed search term is like earthquake tweets. Okay, so now we have discussion about the paper limitation. In my opinion, this paper have a 4 limitation. First one is efficiency, like time and computational thing, and second is testing data, is using data from 2016 from previous research and remove the naval word. What the drawback of the action of the dataset results, because in my opinion, if like a slang of the type of word that people use, it's changing by the time. I think it's the 2016 dataset is more stale, so maybe they could find now another new dataset. And we're talking about relevancy by accuracy. They not give another evaluation testing measurement like recall F1s for or precision. And how about retweet things? Because retweet is only duplicate the data, not give the new search. Okay, let's we think about efficiency and time computational. I think Dust2 is a really dynamic, because they only do a first iteration and then they start to explore it. For Dust1 is a more relevant data. In Dust2 it's a time for exploration. So because they do less for the iteration, maybe they do only take 10 minutes for iteration, just only 1 iteration, because they process it in the same time, so they have more time for exploration. But they need more research, because it's a very high computational. And it's and I think we're talking about the solution about the duplicate takes or collected data tweet. We can exclude the retweet thing, because it can like if we remove the retweet thing, the tweet that comes in our data collection is more be like a sort by removing that thing. And we have to fix Dust algorithm by provide the computation and standard algorithm in terms of bandwidth and computational value. Maybe we can use different evaluation method to measurement the efficiency of this algorithm. And for the data testing, maybe we can use update dataset for accuracy measurement. And what if we use like dynamic multi-arm bandit algorithm? This is the new algorithm. It's MIB, multi-arm bandwidth algorithm, become a dynamic, and bandit is heavily biased to the prior that is cannot quickly adapt itself to a trend that is interchanging. As a result, bandit cannot quickly enough make profitable decision when the trend is changing. So DMIB is quickly detect an abrupt change in the reward of the current base arm, therefore recognizing whenever the optimal operator has just changed and then restarting the reward and confidence record. So this algorithm proposed by Sadek Obari in 2019. Maybe if we use this algorithm replacing the MAB, the result of the new object search sum will be more better than previous research. And about the measurement, what if we use a test bed for dynamic search system, because the track dynamic domain evaluate the search effectiveness of the team of user and search engine for interactive. So they did not separate the user from the search engine. What the user did and what the search system did were evaluated together. And this is the aspect of precision and aspect of recall were the main metric that we use. So what if we use this type of measurement to do like evaluate the performance of algorithm? And what if we exclude the retweet? Like I said before, retweet is only like duplicate the text. There is no new information. It can make our data collection is okay. If we can remove this retweet thing, maybe our data collection and streaming API, it will become more relevant than the others. A retweet is different with a quote tweet, because quote tweet maybe it's contain a new information. For example, if some like a disaster agency teams like tweet for Indonesia, we say it's BMKG did about an earthquake, and I read the tweet, I want to somebody else know, I just do a retweet, I just duplicate the tweet. It's different with a quote tweet. Quote tweet is like adding a new sentences in the tweet before. So maybe when I am I am on the location, I am impacted to the earthquake, maybe I can tweet another information that may be useful for the search disaster agency. So I think to exclude the retweet, it's more efficient to collecting the data. And I think that's all for my presentation. Thank you. I'm sorry if I have a lot of mistake. My pronunciation, maybe I cannot explain more. I'm sorry, and thank you for your attention. Bye.